Okay. So now let's prove its converse part. Okay, conversely assume that that condition holds. Conversely assume that
तो सर
conversely.
हमने इसका पहला पार्ट तो क्या है, हमें खाली लेट लिखना
Okay, ये
है, लेट
actually.
इज अज्यूम्ड।
ओके ये रिकॉर्ड हो गया ना लेक्चर, इसको मैं भी शेयर करूँगा.
ठीक है सर, ठीक
Conversely assume that for all epsilon positive there exists an integer n such that mod of fn plus px minus fn x is less than epsilon for all n greater or equal to n and x belongs to the interval a b. Suppose this thing hold. और आपको प्रूव करना है कि ये जो स्वीगेनस एफ एन इट कन्वर्जेस यूनिफॉर्मली टू व्हाट, टू एफ. ओके, इट कन्वर्जेस यूनिफॉर्मली टू एफ. ये आपको प्रूव करना है. सो तो यहाँ आपको क्या मिलेगा, मतलब ये जो कंडीशन है ना, इस कंडीशन से आपको क्या मिलेगा. हाउ कैन यू डू दैट. इसने कहा भाई कॉशी जनरेटर कन्वर्जेंस एफ एन. इस बुक में बहुत सारी गलतियां हैं. मैं इसको देख रहा हूँ ना, मैं इसकी प्रूफ देख रहा हूँ कि किसी जगह रीजन गलत लिखा है, किसी जगह कुछ नहीं. तो ओके लेट्स सी दिस. इससे आपको क्या मिलेगा, ये जो इनइक्वालिटी है ना, what can you conclude from this inequality. So from this inequality we can see that the sequence f and x of real numbers is a Cauchy sequence. तो Cauchy sequence की definition है because they are actually real numbers here. ये real numbers है. तो अगर आप इस real number को let's denote this real number by say Sn plus p, and let's denote this real number by Sn. So it's actually a sequence of real numbers satisfying this inequality for all n greater or equal to n. So this is the definition of Cauchy sequence actually. वही तो definition है. So Sm minus Sn, m की जगह पर n plus p है, Sm minus Sn less than epsilon. So this is actually the definition of Cauchy sequence. So and it's Cauchy sequence for each x because this holds for each x. So therefore f and x is a Cauchy sequence. Is a Cauchy sequence of real numbers. For all x belongs to the interval AB. And we know that every Cauchy sequence in R is convergent. Now, because R is complete normal linear space, every Cauchy sequence is convergent there. So this sequence is also a convergent sequence. So thus for each x this converges to some function. So thus for all x belongs to AB, there exists, in fact it's unique because limit is unique, there is fx in AB such that there is fx real number, okay, not in AB. There is fx such that this whole is such that mod of fnx minus fx is less than epsilon for all n greater or equal to n. And this is the definition of uniform convergence actually. अब यहाँ पर जो n है ना, अब आप कहोगे कि आपने तो x पहले लिया यहाँ पर, मगर ये n तो मैंने उससे पहले लिया था ना, ये यहाँ पर है एक्चुअली. तो दैट मीन्स दिस n is independent of x actually. Okay, so this implies that this implies fn converges to f. It is straightforward actually. This is straightforward. So this is the Cauchy's general principle for uniform convergence. Now let's see some examples. तो अब इसके बाद सीरीज के लिए भी ऐसा ही एक प्रिंसिपल है. सो लेट्स यू कैन सी दिस एट पेज नंबर 397. तो वो उसने एक्सरसाइज रखी है, उसका प्रूफ फॉलोज एंड सिमिलर लाइन्स. तो सीरीज सीक्वेंस को सीरीज से रिप्लेस करना है. यू कैन गेट द सिमिलर रिजल्ट फॉर सीरीज. सो सम एग्जांपल्स नाउ. Some examples. Some examples. So first example. Example 1. Test for uniform convergence. Test for uniform कन्वर्जेंस. तो जब भी आपको टेस्ट करना होगा यूनिफॉर्म कन्वर्जेंस के लिए, आप सबसे पहले पॉइंट वाइज लिमिट निकालिए और फिर बताइए उसी फंक्शन पर ही यूनिफॉर्म कन्वर्ज हो रही है. ओके, तो टेस्ट फॉर यूनिफॉर्म कन्वर्जेंस of this sequence fnx is equal to this sequence, it's nx divided by 1 plus n square x square, where x is any real number. So this sequence is defined on whole R, not on any particular interval. So first let's see its pointwise limit. Let's approach n to infinity and see. So we have this fnx. Let's dividing throughout by n or n square, throughout by n or n square can divide by n. Okay, it's x divided by then 1 by n plus n square x square by n, that's n x square. And if n is approaching to infinity, this will be a finite because it's a real number. And 1 by n is 0, but n x square is infinity because x square is a non-negative number, so it's n x square, it's infinity. So it's a finite thing divided by infinity, which is equal to 0. So this approaches to 0 for all x naught. For all x naught, we have for all x belongs to R, this holds. So therefore the limit function is actually 0. So thus let this limit function, limit n approach to infinity, fnx is equal to fx. Then what is this fx? Then fx is a 0 function for all x belongs to R. So this converges pointwise to this 0 function. Now let's see that whether this convergence is uniform or not. Okay. So for if fn converges to f uniformly, so then for all epsilon positive, there exists n such that this thing holds 0 function. It's a 0 function here, fn comes 0. So this mod of fnx minus 0 is less than epsilon for all n greater or equal to n. That is, let's substitute the value of this. It's here nx divided by 1 plus n square x square, 1 plus n square x square minus 0, that's less than epsilon for all n greater or equal to n. तो ये मिलना चाहिए अगर यूनिफॉर्म कन्वर्जेंस. and this should hold for all x, okay, for all. So for this converge uniformly on some interval, okay, let's write here on some interval containing 0, in fact, for all x belongs to R, for all x belongs to R. So this holds for all x. For each epsilon positive, there is n which is satisfying this inequality for all n greater or equal to capital N. So let's choose for epsilon equal to 1 by 3, for epsilon equal to 1 by 3, okay. epsilon equal to 1 by 3 के लिए भी तो कोई n x होगा ना, epsilon equal to 1 by 3. So क्योंकि हर किसी एप्सिलॉन के लिए कोई ना कोई इंटीजर मिल रहा है, there exists an integer capital N such that mod of nx divided by 1 plus n square x square less than 1 by 3 for all n greater or equal to capital N and for all x belongs to R. Okay. So let's choose an integer. Let m be an integer. Let m be an integer, small, okay, such that this m is greater or equal to capital N. So then this 1 by m ये real number है, it's a real number, it's a real number. इसका नाम मैं यहाँ पर मैं स्टार लिखूंगा, इसका नाम it's a star. तो आपके पास ये रियल नंबर है, अब ये जो स्टार है आपका, जो ये स्टार है ना, स्टार होल्ड्स फॉर एवरी रियल नंबर है, हर किसी रियल नंबर. इन पर्टिकुलर इट होल्ड्स फॉर 1 by m and also star holds for every integer n greater or equal to capital N. In particular it holds for m because m is also an integer greater or equal to capital N, right? So I can choose n equal to m. So choose, just suppose put, you can put that, there's no harm by putting that. Put n equal to, put m, not n. Put m equal to small n. That I can choose in star because क्योंकि मुझे मैं वही n choose कर सकता हूँ इस स्टार में which is greater or equal to capital N. और ये जो आपने m लिया ना integer, it is an integer which is greater or equal to capital N. So I can choose m equal to n. So I should write this n equal to m क्योंकि n में choose कर रहा हूँ ना. I can choose n to be m, okay? And one more thing, choose x equal to 1 by m there in star. We get the following, okay? We get mod of nx, n is your m, into x is 1 by m, divided by 1 plus n square, n is m, m square, x is 1 by m. This thing is less than 1 by 3, which implies, so m and m will go m square and m square, it is 1 by 1 plus 1, that's 1 by 2 is less than 1 by 3, a contradiction. तो यूनिफॉर्मली कन्वर्जेंट नहीं, तो आपको प्रॉब्लम एक्चुअली कहाँ पर आपको लगी, यहाँ पर देखिए. तो यूनिफॉर्म कन्वर्जेंस का मतलब तो ये है ना, जो मैंने डेफिनेशन यहाँ पर लिख दी है. For if it converges uniformly to 0, then for each epsilon positive I can find and satisfying this. Okay, हर किसी epsilon positive के लिए तो मैं epsilon को कोई भी पॉजिटिव नंबर चूज कर सकता हूँ. Then this inequality should hold for each x in R. तो मैंने epsilon को 1/3 चूज किया, तो 1/3 के लिए भी कोई ना कोई कैपिटल N एग्जिस्ट होगा और ये इनइक्वालिटी होल्ड होगी फॉर ईच x इन R, जो मैंने आगे किया है. नेक्स्ट पेज पर मैंने क्या लिया, epsilon equal to 1/3. So for this epsilon, for this particular value of epsilon, I can find some particular integer n, such that this thing hold for each n greater or equal to capital N, and for each x in R. तो मैं कोई भी रियल नंबर अब चूज कर सकता हूँ, उस रियल नंबर के लिए ये इनइक्वालिटी होल्ड होनी चाहिए, प्रोवाइडेड दैट दिस स्मॉल n is greater or equal to capital N. So now what I will do, I will choose an integer small m which is greater than capital N, okay, and then corresponding to this integer I can find a real number 1/m, which is obviously a rational number also, it's a real number, and then putting n equal to m, that I can do because m is greater or equal to n, and by putting x equal to 1/m, that I can also do because star holds for every real number, so this is one of the real number, so we get this. तो ये this capital N is it's an integer which is very large integer. Okay, so this thing hold for each n greater or equal to capital N. So m जो है ना, m आपने integer लिया which is greater or equal to capital N. So this 1/m is a very small real number. So then I can say this. So therefore I can say this. Therefore, f and x does not converge to f uniformly on any interval, किसी भी interval पर, not on R or only on any interval containing 0, जिसमें 0 होगा, क्योंकि जिस इंटरवल में 0 होगा वहां पर आप रियल नंबर चूज कर सकते हो, 1/m where m is a very large integer containing 0. But this you can verify. F n converges to f uniformly on this interval k to say b, where k is positive. इस इंटरवल पर ये कन्वर्ज करेगी यूनिफॉर्मली. आप इसको वेरीफाई कर सकते हो. You can verify this. This is very simple. One more example. Example 2. Show that the sequence Fn defined by x power n is uniformly convergent. Is uniformly convergent on this interval, on interval 0 to k, where this k is strictly less than 1 and only point-wise convergent, and only point-wise convergent and only point-wise convergent on this interval 0 to 1. Okay. So let's first check the uniform convergence. So first we'll find its limit function, पॉइंट-वाइज लिमिट. जब भी यूनिफॉर्म कन्वर्जेंस आपको चेक करना होगा तो सबसे पहले आपको लिमिट फंक्शन निकालनी होगी. सो दैट्स ऑलवेज पॉइंट वाइज लिमिट है. तो फिर आपको चेक करना वो जो पॉइंट वाइज लिमिट है वो यूनिफॉर्म लिमिट है या नहीं है. तो देखिए अगर इसका लिमिट लेट लिमिट एन अप्रोच टू इन्फिनिटी f and x is equal to f of x. Suppose its limit, point-wise limit is this f. It's a point-wise limit, okay? Point-wise. Yeah, अगर मैं लिखूँ for all x in the interval 0, 1, let's suppose that this be its limit. Then what's the value of fx? Then you can see this fx is equal to, then fx is this. It's equal to the 0 for 0 less or equal to x less than 1, and for x equal to 1 its limit is 1 for x equal to 1. Because the frequency is x power n, so whenever x is less than 1 the powers will decrease, okay? So whenever x equal to 1, its 1 power n is always equal to 1, so its limit is also equal to 1. So this is the point-wise limit. This is the point-wise limit. So now suppose this x is less than 1, okay? So let 0 less or equal to x and x is less or equal to k and k is less than 1, okay? Then let's see this difference. Fn x minus fx. I want to see that this difference is less than epsilon for all n greater or equal to capital N, and that capital N should independent of x actually. So first let's check the difference. This is equal to the for 0 less than x, x less than 1, the limit function is 0 and fn x is x power n, it's x power n minus 0, and this is equal to mod of x power n, so which same as x power n because x is positive, and this thing is less than epsilon. ये less than epsilon होगा whenever what? Whenever you can apply the log here, then n times log x, or you can say this whenever whenever okay, n times log of x, n times log of x is less than log epsilon, okay? First I think should first do this whenever because I want to convert it into greater than. So this is less than epsilon whenever 1 by x power n, 1 by x whole power n is greater than 1 by epsilon. That is mod of fn x minus fx is less than epsilon whenever 1 by x power n, उसमें आप log अप्लाई करोगे whenever log of n times log of 1 by x is greater than log of 1 by epsilon. That is mod of fn x minus f of x, it's the 0 function here, less than epsilon whenever this n it's greater than log of 1 by epsilon divided by log of 1 by x. But this is an increasing function. I think this is an increasing function with x, and this thing it increases whenever n is greater than this, so we can choose its maximum value I can choose its maximum value. So so the maximum value of this thing is अगर आप इसका maximum value निकालना चाहोगे ना since वो मैं यहाँ पर लिख दूंगा since the maximum value of log of 1 by epsilon divided by log of 1 by x where 0 less or equal to x less or equal to k and k is less than 1, its maximum value is equal to log of 1 by epsilon, क्योंकि ये increasing function, you can check it, it's increasing function, 1 by k. So actually ये जो है ना 1 by x जो है ना x increasing है 1 by x decreasing, okay, तो 1 by x तो है ही decreasing, log of 1 by x भी decreasing आ जाएगी, but it's in the denominator now, so 1 by log of 1 by x जो होगी वो increasing, so it's increasing function. So its upper bound will be this, so its upper bound will be at k पर इसका upper bound होगा because it's increasing function. So therefore mod of f n x minus f of x is less than epsilon for all and whenever n is greater or equal to this maximum value, greater or equal to this. So whenever n is greater or equal to maximum value, it means that n is greater or equal to log of 1 by epsilon log of 1 by x. Also for each x, log of 1 by epsilon divided by log of 1 by k. Okay, so now let's choose an integer. Choose an integer capital N which is greater or equal to log of 1 by epsilon divided by log of 1 by k, then mod of f n x minus f of x is less than epsilon for all whenever or for all n greater or equal to capital N and x belongs to the and x belongs to the interval 0 to k. So therefore fn converges to f uniformly on the interval 0 to k where this k is less than 1. K is less than 1. So obviously आप अगर इसमें 1 भी होगा ना, उस केस में आप इसका मैक्सिमम वैल्यू नहीं निकाल सकते क्योंकि यहाँ पर log of 1 by x है. For x equal to 1 it will be log of 1 which is equal to log of 1 is 0 and log of 1 is 0, so it will be log of 1 by epsilon divided by 0 which is equal to infinity. So we cannot define n at that moment if this interval will contain 1 also, क्योंकि इंक्रीजिंग है तो 1 पर इसका वैल्यू इन्फिनिटी है. So however log of 1 by epsilon divided by log of 1 by x, this will approach to infinity as k approaches to 1. So thus we cannot find capital N. Thus fn does not converge to f. It does not converge to f uniformly on this interval 0 to 1. तो आज हम इसमें इतना ही करेंगे. हाँ, थैंक यू. एंड दिस लेक्चर नाउ. इसमें कुछ नेटवर्क इशू था।